Welcome to my AI Newsfeed 2020-60602. Today's 11 stories. Story 1, Google I.O. 2026 showcases Gemini AI and agentic features. Story 2, AI News Today, May 24, 2026. 11 biggest stories including OpenAI IPO. Story 3, AI Benchmarks 2026, MMLU, GPQA, SWE-bench, LM market cap. Story 4, New AI model releases, latest AI models released today. Story 5, Tiger, traceable inference with graph-based evidence routing for mitigating hallucinations in multimodal generation. Story 6, evaluating interactive reasoning in large language models, a hierarchical benchmark with executable games. Story 7, Cast, non-privileged clipped asymmetric self-teaching with advantage flipping for GRPO. Story 8, Emergent collaborative deliberation in multimodal AI systems, a BFT-derived protocol for epistemic synthesis. Story 9, a multi-AI agent framework enabling end-to-end finite element analysis for solid mechanics problems. Story 10, Launch HN, Expanse YCP26, unlock wasted GPU capacity. Story 11, data on AI capabilities and benchmarking Epoch AI. A startup out of Y Combinator's P26 batch is taking aim at one of the most costly and underappreciated inefficiencies in modern computing: the massive waste sitting idle inside GPU and HPC clusters every single day. The company is called Expanse, and it was founded by 4 engineers who spent years running high-performance computing workloads at some of the world's most demanding institutions, including national supercomputing centers and quantitative trading firms. The problem Expanse is solving stems from a very rational but collectively destructive behavior. When a researcher submits a job to a cluster and requests too few resources, the job dies mid-run. They could lose days or even weeks of computation. So naturally, everyone hedges. They request 2 or 3 times more GPU memory, CPU cores, and storage than they actually need. The result is a cluster that looks busy on paper but is deeply underutilized in practice. Expanse measured one national-scale HPC cluster for an entire month, analyzing over 122,000 jobs, and found that 59% of all compute was simply wasted. At on-demand cloud rates for equivalent hardware, that single cluster burned through roughly $8.5 million of compute in just 1 month. And this pattern holds across AI labs, quantitative funds, and large-scale manufacturing operations. Expanse's solution is to predict what a job actually needs before the cluster ever sees it. The system reads the job's source code, its submission script, and live hardware telemetry from the cluster, then feeds all of that into deep learning models to generate accurate resource recommendations at submission time. It also flags jobs likely to fail and surfaces line-level optimizations for researchers. The models are cluster-specific, trained on your hardware, and get sharper over time as more workloads run through them. The founding team built the core prediction engine at Edinburgh's Parallel Computing Centre, the UK's national supercomputing site. That initial model outperformed every existing baseline by 34% and beat frontier general-purpose language models on the same task by roughly 8 times. That performance gap makes intuitive sense. Task-specific models trained on real hardware telemetry capture signals that general-purpose AI simply cannot. The implications here go well beyond cost savings. At a time when GPU supply is severely constrained and organizations are waiting months for access to compute clusters, recovering wasted capacity without buying new hardware is extraordinarily valuable. Expanse represents a new category of infrastructure intelligence, software, that makes existing hardware radically more productive. Epoch AI is one of the most important organizations you may not have heard of, and their continuously updated AI benchmarking database represents a critical piece of infrastructure for understanding where artificial intelligence actually stands today. Updated as recently as June 2, 2026, the database tracks performance of the world's leading AI models across more than 40 distinct benchmarks spanning mathematics, software engineering, scientific reasoning, games, long context understanding, and multimodal tasks. It is trusted by researchers at OpenAI, DeepMind, and governments around the world. And for good reason, because independent, systematic benchmarking is genuinely scarce in a field where capability claims are frequently contested and selectively disclosed. The most significant recent data points tell a nuanced story about the current AI landscape. As of late May 2026, Epoch's analysis shows that open-weight models, the publicly available AI systems that anyone can download and run, have consistently lagged behind the proprietary frontier by approximately 4 months throughout 2026. That is simultaneously encouraging and sobering. Encouraging because the open-source ecosystem is tracking elite commercial AI with remarkable speed. Sobering because the gap has not closed, meaning the most powerful AI capabilities remain concentrated in a handful of commercial laboratories. On the proprietary side, GPT-5.5 Pro recently set a new record on the Epoch Capabilities Index, achieving a score of 159, the highest yet recorded. And in April, Epoch released early results from a new benchmark called Mirror Code, co-developed with the AI Safety Evaluation Organization, METR, which tests something qualitatively different from prior benchmarks: AI's ability to complete weeks-long coding tasks. The finding that AI systems can already complete some such tasks is a significant milestone, suggesting that autonomous AI software engineering is not a distant future scenario, but an emerging present reality. What makes Epoch AI's work particularly valuable is its methodological rigor and independence. In a field where model developers have obvious incentives to present favorable evaluation results, an organization that runs its own internal evaluations on challenging benchmarks like Frontier Math and GPQA Diamond provides a crucial check on self-reported claims. As AI capabilities continue advancing rapidly, this kind of independent measurement infrastructure is becoming as important to society as the models themselves. One of the most fundamental challenges in building AI that can genuinely help people is giving machines the ability to understand what humans are thinking, not just what they say, but what they believe, want, and intend. This capacity, known as theory of mind, is something humans develop naturally in early childhood, but it has proven remarkably difficult to instill in artificial intelligence. A new paper called MindZero, accepted at the premier machine learning conference ICML 2026, takes a significant step towards solving this problem, and it does so without requiring any labeled data about human mental states at all. The core challenge the researchers faced is straightforward. To train an AI to infer mental states, you normally need someone to annotate what a person was thinking at each moment. That is expensive, subjective, and largely impossible to scale to real-world behavioral data. MindZero sidesteps this entirely with a clever self-supervised approach. During training, the model generates hypotheses about what a person believes or wants, and it gets rewarded when those hypotheses successfully predict what the person does next. In other words, if your mental state theory correctly anticipates behavior, it gets reinforced. This mirrors how humans naturally develop social understanding, through observation and prediction, not explicit instruction. The results are striking. Pure language models, even frontier-scale systems, were found to be insufficient for robust theory of mind reasoning. Model-based methods that reason explicitly about mental states do better on accuracy, but are too slow and expensive for real-time use. MindZero threads this needle. After training, it internalizes the model-based reasoning into fast single-pass inference, achieving better accuracy than model-based approaches while running efficiently enough for real-world applications. The implications are broad. AI assistants that can infer user intent from behavior without requiring explicit commands could transform robotics, smart home systems, and human-computer interaction. The self-supervised training approach means this capability could potentially be trained on the massive quantities of human behavioral data that already exist, without the bottleneck of manual annotation. The team evaluated their system in grid world and household simulation environments, so real-world validation remains the next critical step. But Mind Zero represents a genuinely novel and practically promising advance in social AI. A daily updated tracker of new AI model launches from major labs including OpenAI, Anthropic, Google, Meta, and Mistral. Covers model specs and availability, serving as a useful reference for staying current on the rapidly evolving model landscape. Tiger proposes a fact-level repair system for multimodal LLMs that uses graph-based evidence routing to identify and correct unsupported claims in generated outputs. Unlike prior approaches, it avoids letting hallucinated content bias the model's reading of inputs and enables ranking of corrections at the fact level. This paper introduces a multi-turn interactive benchmark for LLMs that frames reasoning as active evidence acquisition rather than single-pass Q&A. LLMs must query a hidden environment, integrate partial observations, and update beliefs, testing a more realistic and challenging form of reasoning. CAST addresses a key weakness in GRPO-based reinforcement learning for LLMs, the vanishing advantage signal when all sampled trajectories are uniformly correct or incorrect. By combining asymmetric self-teaching with advantage flipping, it provides denser supervision signals for improving reasoning capabilities. The Concilium protocol introduces a Byzantine fault tolerance-inspired framework for structured deliberation among multiple AI models, treating disagreement as useful epistemic signal rather than noise. It assigns distinct cognitive personas to models and uses a finance-inspired validation framework to separate in-distribution from out-of-distribution reasoning. A box agent is a multi-agent AI framework that automates end-to-end finite element analysis, FEA, for solid mechanics, lowering the barrier for entry-level engineers and reducing errors in simulation setup. This is a practical agentic AI application in the engineering domain. Expanse is a Y Combinator-backed startup that improves effective capacity utilization of HPC and GPU clusters running Kubernetes or SLURM. By analyzing job scripts and hardware specs, it predicts actual resource needs before scheduling and flags likely failures, directly addressing GPU waste in AI training infrastructure. Epoch AI's benchmark database tracks performance of leading AI models on challenging tasks, combining internally evaluated results with external sources. It enables trend analysis of AI capabilities over time and across model families.